Hello, hi, and welcome to this webinar on DashCanvas and interactive image processing. My name is Emma. I'm a physics researcher, and I'm working with Plotly on image processing and developing Dash apps for image processing. So the back, okay. Hi there, so hope you can all see me, and we will start this webinar on interactive image processing with DashCanvas. And so, as you know, Dash is a framework for creating web applications, especially analytical web applications, only with Python. And so can you, I hope we are okay with the sound and the mic. And so now I will share my screen so that you can see this webinar. I hope the screen sharing is working well, and we will see our first hope you can see. Yeah, you can see the screen fine. Okay, good. So the typical apps we are going to see today are apps where we draw on images, and then based on this annotations, we perform image processing tasks such as here segmentation or registration and so on and so forth. So the tool which I'm developing is called DashCanvas. It lives on Plotly /DashCanvas in GitHub, and so you can first pip install it with so pip install DashCanvas, so like this. Let me minimize my screen. So like this, pip install DashCanvas. It will also install the required dependencies such as Dash or Dash core components. Okay, so once you have installed the DashCanvas package, then we will create our first DashCanvas object. And so this is the code for it. So you import DashCanvas, and from it you import the DashCanvas object. And so this is a Dash app where in the layout of the app you have this DashCanvas object. So what happens when you run the app? So it's Python, the name of the app.py, and we will see our first app. So here it is. We have a screen with a pad on which we can draw. We can draw freehand lines. We can also draw like straight lines. We can move object around. If we're not happy with the result, we can also undo and so on. DashCanvas is really this object, this pad on which you can draw. And it has a number of options with default values. So if now we want to customize a bit more, like the properties of the line, we can go to this second example here on my screen, where you see that different keyword arguments have different values. We ask for red line color. We change the dimensions of the screen. If you want to know more about these different options, then you can take a look at the doc string of DashCanvas. So we do from DashCanvas import DashCanvas. And let's take a look at the doc string. You see that it has quite a large number of different options. So here is the second example. And now we see that the line is red, that the line is also thinner. And when we change with the different buttons, we can have these different tools. But so when creating the DashCanvas object, we have this different options, which we can customize them. Okay, so we can also, of course, if we want to do image processing, we need images, because just drawing is not so nice. And for this, so it's my next example. The DashCanvas the DashCanvas object is taking an option, a keyword argument, which is file name, and file name can be the URL of an image, and this will allow you to have the image as a background. So when we do this, so we have the DashCanvas with this image, which I took from Wikipedia, which is a biology image. So this is good. We can draw on the image and so on. However, if I don't specify the dimensions on the image, the dimensions of the canvas do not fit with the dimensions of the image. And this is why, in addition to just giving the file name, the location of the image, we also need to change the dimensions of the canvas, which I do here, computing the height and width of the image and making sure that the canvas weight has the same aspect ratio as the image. And we also have a scale parameter, which is the zooming factor to fit the image in the canvas. So if we do this and we refresh the app, here it is. You see that now the image fits well into the canvas. Okay, so once again, we can draw on the image. We can do some drawing, but when we want to do image processing, we now need to add callbacks to our apps. And so just to give you a short idea of how DashCanvas works, when you draw on the image, and so it creates a JSON string with the geometry of the annotations. And when you press this button, then you retrieve this JSON string, and you're able to pass it to other parts of your app so that you can trigger callbacks using these annotations. So let us take a first example, which is a very simple image processing task, where what we want to do is to measure things on an image. Let's say I have this radiography of an elbow, and I'm a medical doctor. I want to see if the bones have the right dimension. So I will have this line tool, which I can draw at meaningful locations. And then when I click on measure, a dash table is populated. It's like a pandas data frame, but in your dash application. And it has the geometrical information of these lines. Okay, so this is really one of the most simplest things that one would like to do in image processing. And the way it works is really by retrieving the geometry as a JSON string, and behind the scene, so the DashCanvas package has utility functions to process the annotations. For example, to return a pandas data frame, or to do some other operations on this annotations. So we can take a look at the code of this app. So here it is. Because it's our first app which is using callbacks. So once again, we have defined the DashCanvas object here. We see that the tool we have selected is a line, because here we don't want to draw freehand lines, we want to measure lines. And then we have this data table, which will contain the result of our measurements. And we have one single callback here, which takes as input the JSON data of our DashCanvas. So this JSON string with the annotations. And it calls a utility function of DashCanvas, which is able to parse the JSON string in the case of lines. And after, it creates a data frame with this numerical information, and returns the data with the right format for the data, for the Dash data table. Okay, so this was a first example of a DashCanvas app for interactive image processing, measuring the geometry of objects. Now let's do something which is even more fun and a bit more complex. What we want to do now is to take this picture and to remove the background of the image. We want just the lady and not the background. It could be, for example, for obtaining ground truths for training a machine learning model, or it could be like if you're in the retail industry and you want to have very nice pictures for your website, etc. So for this app, I draw on the part which I want to separate from the background. I have this slider for increasing the brush width. Okay. And I draw a little bit on it. For the finer details, I can decrease the size of the brush, like for the arms. It's really like drawing, but in your computer. And so after I hit the remove background button, and so you see that the result is quite good, but not perfect. So let us add some lines here. No, it's not so good. So we'll use the undo button, and like here, how it is, we do it again. Okay, now we have the hair. So it's pretty cool. We have separated the character from the background. Hope you find it cool. And so the way it works is that this app behind the scene is using Other scientific Python packages such as scikit-learn and scikit-image, which are packages for respectively machine learning and image processing. I'm also a core developer of scikit-image, so I'm really interested in image processing. And so when you draw on this image, then there is a machine learning model which will compute features for the pixels and use as a training set the pixels that you annotated and pixels which are far apart, defining two classes, and then try to predict whether the other pixels are background or object. And in fact, it's using a super pixel algorithm of scikit-image in order to keep some spatial proximity between pixels. But I mean, the purpose here is not to do a webinar on image processing. It's just to show you that with interactivity, you can accelerate a lot your image processing workflow. Okay, so I have a few other demos to show. I hope that the microphone and the screen are still okay. And so in before I move to other examples, let me just show you the source code of this new app on background removal. So here we have the DashCanvas object. And one thing which is quite interesting to note is that here you might have noticed that we have less buttons than in other apps. Like here we had a whole line of buttons in the toolbar, and this is a feature which you have in DashCanvas in case you don't want to confuse your users with a lot of different buttons. Like here we just needed the brush and not the line tool, for example. So we have this option which is hide buttons, where you can decide which buttons you want to hide, so that you can customize your toolbar. Then you have a few callbacks, and so the one which is calling the segmentation is this superpixel color segmentation function. And the callback is, again, using the JSON data, which is a geometry of the annotation. And this superpixel color segmentation function is also a function of DashCanvas. It's here in the utils.image processing submodule of DashCanvas, where you have a lot of utility functions which can massage and process your annotations and which then call scikit-image or OpenCV functions to do the actual image processing work. Okay, so now I can show you very briefly, before taking questions, a few other web applications. And so now you might get a feeling of how DashCanvas works. So the principle is that you will do a high-level image processing task using the interactivity which DashCanvas can give you. And so you define annotations, and then you write the callbacks, which will process these annotations for image processing. So in this app, the purpose is a bit different. The purpose is to do post-processing of segmentation. So in this image, the yellow line represents a previous automatic segmentation which was done. And let's say I'm not very happy with the segmentation. I think that, for example, this object should be split in two, this one too, and so on. So I draw approximate lines where I want to separate the objects, and then I update the segmentation. So when I'm not happy with the result, I can instead merge the objects. So this one was really not good. And so when I update, you see that it's merged again. And to finish with this different apps, I will show a stitching, an image stitching app, where let's say that you had different images of the same sample, but taken at different places, and you want to stitch them into one image. So one way is to do it automatically using algorithms of scikit-image. Here you see that the image has been turned into one, but sometimes you have images for which it's quite difficult to do the stitching automatically because you don't have enough overlap between the images, for example. And for this, what you can do with DashCanvas is like to draw a line linking similar points in pairs of images, like here, or here, for example, it can be like here. And then I estimate the translation, and here it fills once again a dash data table, and then I do the stitching once again. So I went quite quickly through all these different apps. So if you want to see once again the different apps, you can find them on my GitHub account here. It's GitHub Emmanuel, and my most recent repository. Where is it? So it's here. Okay, so it's Emmanuel DashCanvas webinar on GitHub, and you have all the different apps, and you also have the files necessary for the apps. You just need to pip install DashCanvas before. So let me see now if if there are a few questions. So I don't know if there are some questions. Let me just wait for a second to know if there are questions, sorry. Thank you for the kind words on the chat. And so before, I don't know if you have questions. So let me just say that if you want to contribute to DashCanvas, so first the project is quite alpha. It's the development has started not a long time ago, so we're still developing features. For example, what we would like to do is that adding an image as background is smoother and easier. The size of the canvas updates automatically. We also would like to have a resizable canvas, for example. So if you're interested, please go to the GitHub of DashCanvas, and you can file an issue about requests for features, or we're also very interested in knowing more about your potential use cases, what you would be interested in using DashCanvas for. And last but not least, DashCanvas is an open source project. It has an MIT license. So if you would like to contribute to the development of a cool and exciting library, you're very welcome. I would be very happy to work with you. And of course, if your company wants also to sponsor some development related to image processing and DashCanvas, it's also very welcome. So as it seems that there are no questions, I will show this this first example that I showed at the very beginning. So the that segmentation algorithms, which will segment the object using the annotations as markers. So here we use the watershed, and which will do the segmentation starting from the markers and then invading the rest of the image until it hits. Then the results should, oh, sorry, it's, yeah. But by the way, this was not on my local computer. The apps are also hosted in DashCanvas.Heroku app. the to and use